everyone for coming and learning about certificates of analysis first thing in the morning, or I guess second thing in the morning. So I know it's maybe not the most riveting subject, but hopefully this is a useful presentation. Whether you've ever seen a certificate of analysis or this is the first time you're hearing it, I'd like it to be a kind of introduction so that everyone knows how to understand these complicated pieces of paper that are really important in the industry. And so that's the goal today, and hopefully we can achieve that to some degree. So briefly, kind of my background and why I know far too much about certificates of analysis. So I have a PhD in chemistry, and so really understand the molecular aspect of it, but also the CEO at Treehouse, where we have two different branches. One really focused on research and development, and that's of the minor cannabinoids or the really rare cannabinoids, so isolating them or being able to convert one cannabinoid into another, things like that, very basic science. And then on the other side, we do a lot of hemp extraction and production of hemp-derived ingredients, and so we see the kind of entire supply chain from hemp all the way to kind of final products, and that's where the certificate of analysis becomes very important at each step in that process. So that's a bit about me and why we deal so much with certificates of analysis. And now I'm just going to walk through, this is the process for hemp in particular in CBD production, but you can think of it with marijuana strains as well. So you obviously have the farming, then you go through your kind of flower processing, which can introduce different things, whether it's adding metals or changing the cannabinoid content from the kind of raw flowering strain to maybe some sort of ground up material. Then there's extraction. You can do a bunch of different steps downstream. So you can end up with just an extract, or you can get distillation, isolation to make different cannabinoid products. And so at every step in this, it's very important to know what the cannabinoid content is, because that's what a lot of people care about, but also the terpenes, what's happening throughout these different steps. If you're using chemicals, what's happening to the product as far as chemical contamination, hemp, heavy metals, pesticides in the growing side, and is that getting all the way through to a final product? And so that's what certificates of analysis really do, is they enable you to see all these different chemical aspects. And the thing with chemicals is you can't see them without really fancy instrumentation, right? You can't take a microscope and look for CBD content, and you can't take a microscope and look for pesticide content. It has to be these kind of fancy chemical instruments. And so understanding how to read the reports that you get when you get these different tests is very important. And so I'm going to start with these kind of 101 level questions that we see all the time, and so I think it's a good starting point for, if you've never heard of this before, what is a certificate of analysis? What test should your hemp or marijuana be subjected to? What are you trying to figure out at that level? Once you get ingredients, what tests should you be looking for there? How do you then interpret these pretty complicated pieces of paper? And how can you trust the results or know that they're accurate? So that's what I'm going to answer in the first part of this talk, and then we'll go to 102 questions in the second half of the talk. So just to get started, the certificate of analysis is a piece of paper that gives you the information on any one of these tests that are relevant to the cannabis industry. So heavy metals is looking for things like lead, arsenic, cadmium, those sort of things, whether it's in the hemp or the final product. Pesticides, pretty self-explanatory, looking for pesticides in the hemp or final product. Residual solvents, cannabinoid potency, and so these are the general ones, and now I'm going to go through an example of what an actual COA looks like that for each of those tests. And then the question of trust I'll address right now is that there are international kind of governing bodies, so ISO is the main one, that globally regulates a lot of the standardized testing in all sorts of industries. And so though it's not required right now in the cannabis industry to get tested at ISO accredited labs, that is kind of what drug companies, food companies, a lot of other people use as their standard body. And so though it's not required, I always kind of recommend, if you're looking at test results, a good starting place is to look for ISO accredited labs that will then provide you with those test results that are at least more trustworthy than a lab that has no certification, right? So now this is just the header of a certificate of analysis we pulled. And so again, in the effort of understanding this, if you've never seen them before, you kind of have your company on this side. This is then the testing lab. And so this is an ISO accredited lab. So you get all sorts of kind of data control as far as, when is the report filed, what's the final entry date, what is this code as far as batching, and so that's all required by ISO so that every single sample that goes into that lab has a very unique code, and that data can be retrieved at any point in time, and also it can't be manipulated. So that's very important, and that's just general certificate of analysis stuff. Then this is a heavy metal test in particular, and so you're seeing, again, arsenic, cadmium, mercury, and lead tested for here, and this I think is a hemp material. And so you're seeing, it might be really hard to see, so I apologize on that, but there's 0.187 parts per million of arsenic. And then the kind of question is how to interpret those results, right? So, there is never zero of really anything, and so seeing very small amounts, the next question is how do we know if that's a lot or a little, or should we be worried about? And again, I'll get to that in the second half of the talk. So the next sort of standard test that's important in the industry is a cannabinoid potency test. And again, this is probably hard to see, but you see the compound they're looking for. And so these are a bunch of different cannabinoids. And then the limit of LOQ stands for limit of quantitation. And so that's the smallest amount that the instrument or facility is able to accurately quantify. So that's what the Q stands for, quantitation. So anything below that number in this column, they can't quantify, and so it will come up as zero. And so this is important in particular in the hemp industry because people are very concerned about THC levels. And so if you hear zero THC, that would mean that it's below the limit of quantification, but it's not, usually truly zero. You can always do better and more advanced tests to see that teeny amount. But for all intents and purposes, if a thing is below the limit of quantitation, it's not really there. So that's an important factor. Then you get the reported amount here, and so again, all these zeros are just saying it was below the limit of quantification, and that's why that's showing up as zero. And then you get a little bit of THC, a little bit of THCA, and just the other cannabinoids. And so that's kind of the importance of this one, and this is a kind of a hemp test result. But it's very important then to think about the cannabinoids in the final product. If you're paying for 20% CBD, you want to see this showing 20% CBD so that you know you're getting what you pay for, especially because these are pretty expensive products. Again, I won't belabor the point here, but these are just a bunch of pesticides, and then all of these over here are showing that it was less than the limit of quantification. So you get the little less than sign. So again, it's not zero, but it's at least below the detectable amount. And so this is, a good batch. But you do see numbers here which could scare people, right? Oh, why is there less than 0.05? Does that mean there was some pesticide? It's just saying they couldn't detect it, and that's good to go. Next, you have residual solvents, which again is as you process the plant to make extract oils, distillate, stuff like that, you can introduce a lot of solvents into the process in an effort to purify these chemicals. And so in the final product, you then get, instead of a limit of quantification here, you get a reportable range. And that's showing you we're detecting from minimum 100 on this propane up to 2,000. And so you would get results-wise, zero means it's below that 100. And then the other option would be anywhere in that 100 to 2,000, you would get an actual number. So right here, with heptane, you get 100 to 2,000, and so there's 149 parts per million heptane. But if it was over 2,000, you would get a greater than 2,000, so kind of off the charts, which is, with solvents, not a good thing, right? Anything off the charts is never good. You see different numbers here too, so all of these say 2,000, and then with hexane and benzene, you have like very specific numbers, 0.2 to 4, and the question is, why is that so specific? So solvents have different standards for how much can be in food, and that's regulated by the USP, United States Pharmacopoeia. And so hexane and benzene are known to be worse for humans, and so they have very strict limits. You cannot have more than 120 parts per million hexane in a food product, and you can't have more benzene than 4 parts per million. So, they're both zero here, so that's good, but with heptanes, you see 149, and the question is kind of, how do you interpret that? And I'll get more to that in the next half as well, of how to start interpreting these things. So I guess we're kind of moving on to that now, of the 102 questions. And so again, a little bit more focus on CBD results, but this is broadly applicable to THC, marijuana, hemp strains, whatever, of, why does a product have more than 100% CBD? Isn't that impossible? That's a common question we get in the industry. Why are different labs giving us different results? Like, shouldn't everyone give you the exact same number? Why does a product vary in potency from a couple batches? If you're doing a very standardized process, why is it going up and down when you keep testing this product? And then again, this one I was touching on just now. I see a little bit of residual solvent. Should I be scared? Is that okay? How do I interpret that? And same thing, are there heavy metals? Is this gonna, am I gonna get lead poisoning, Mad Hatter's disease in a couple of years from eating this product, or should I not really be worried? So that's where I'm gonna go next, of how to now interpret the results that come from these certificates of analysis. So here's, again, same lab that I showed previously, showing 102% CBD, which violates the laws of physics. You cannot have more than 100% of anything. And so now, to understand why this happens and why this isn't technically a wrong result, this is a within the range of reportable error result, we have to go into start. I guess first, before I do that, I'll talk about the variance as well. So sorry about that. But so this is now the same exact product, and these numbers are probably impossible to see out there. But it's the same exact product tested from 3 different labs and 2 retests within the same lab. And in every one, you can look at the CBD percentage. You get 96.72, 98.14, 95.9 there, and then here for CBD, you get 81%. So 3 of them are pretty close, right? 96, 97, 98, and one's down here at 80. And now the question for both why you can get over 100% and why all of these things of the test of the exact same product are different, we have to get into air propagation, precision, accuracy, and really, I'm not going to go into this, so this is just to scare some people, I guess, but it's a very complicated thing to actually understand why this air propagates, but I think I have a better, more understandable metaphor. But truly to detect on these parts per million, you get into a lot of math that tells you why this error happens. But I think a better analogy is, how much does this apple weigh? So an average apple, we'll say, is 100 grams. And if you weighed it on all these different instruments, you would get a very different result, right? So we'll say the apple weighs 100 grams, but if you put it on this scale, it might be a red and a blue block. And that's an accurate measurement within that system of, you put on the scale, it balanced out, and that's the accuracy of that one scale. If you put it on your at-home scale, you would have 0 grams, and that apple doesn't exist anymore, but it's there. If you had a kitchen scale, you get a little bit more accuracy there, and if you have a fancy chemistry balance, you get a lot more accuracy. And so that's your first measurement in any sort of thing. Now imagine you cut this apple into 10 pieces. You would think, you would get equal pieces, 10 grams each. But in reality, not every piece is identical. And so now you have pieces that are slightly different at that next measurement point, and then you put that in a pie and bake it. You're going to have each slice of that pie is not going to have exactly 10 grams of apple. It's going to vary, and it will really vary depending on how much apple you measured putting in it at the very beginning. And so in cannabis, you can think of this as you have you're measuring the cannabinoid potency of a hemp flower. So you get the flower, and first you have to mass how much flour it is. So say there's 1 gram of flour. Then you have to first grind it up, and in that grinding up step, you kind of maybe some dust floats away and the mass changes a little bit. Then you have to dissolve it in a liquid so you can put it on these instruments. And so now you're adding some amount of liquid to it, and you could very precisely say add 1 milliliter of liquid, but that's going to have error as well, right? It could be 1.1 milliliter, or it could be 9.9 milliliters. And then you mix that, and then you usually have to dilute it again, and so now you're adding another measurement. And so every one of those measurements has a plus or minus, and it can be 5% or 10%, and all of those plus or minuses compound. And so by the end of the day, if you were measuring something that's very pure, like 100% CBD isolate, plus or minus 2%, plus or minus 5% is an actual repeatable result. And then going back to This one here, these are all within the range of error. So we have 96 plus or minus 2% means that this is 96 plus or minus 2%, and 98 right here, but again, that's within the plus or minus 2%. This one over here at 80 is telling you that this is a very bad test, right? Like 80% is not anywhere near that 96 plus or minus 2%. And so you get variance within labs and between labs, but you can also tell by doing this many tests, you can tell which the bad lab is, right? All of these 3 tests give you a pretty similar result. This one's way off, so that's not a very trustworthy result, and maybe in the future you wouldn't want to use that lab. So that's kind of the testing, and then you also get into, with this error propagation, accuracy and precision. And so in that example there, 3 of them were kind of very close to this 96%, and then 1 was way off. And so in this metaphor, that would be a measurement over here. And so the kind of 2 concepts here are accuracy is getting to the actual right number, and precision is being close together. So you can get very precise results and be wrong on all those results. And so what you want is to be both accurate and precise, and that's kind of the main goal of all of this. So each measurement down the line, you want it to be accurate, precise, and really kind of hone in on what the number is. But because these molecules are impossible to see with the eye, it does take a lot of effort to kind of get those accurate results. Now getting into the end here of interpreting some of these results is residual solvents and heavy metals. And so first off, there's regulating bodies that can help you interpret these results. And so the USP has a lot of information on the residual solvents that occur in things, and that's kind of the main guideline for what can and can't be in food products. Depends on the way you're consuming it as well, right? If there's a bit of solvent in a food product that you're taking once a day, that's fine. If that same amount of solvent is in something you're smoking and is going directly into your system, that might be a different case. And so you have to think about how you're actually consuming the products. There's the FDA, which regulates food and drugs. CBD and marijuana are in a unique spot because they're not FDA regulated and they don't have standards. And so that's why it is, in general, very important to actually look for the COAs yourself. And it puts a lot of onus on the consumers and producers because there's not some regulating body going around saying you broke the rules, because there are no rules. And so understanding these certificates yourself, again, it's a kind of a lot of learning you have to do, but it's the best way to vet whether it's flour or a product you're putting in your body, because the FDA is not doing it right now. So there is no trust there. And then for some other things like heavy metals, you have the Environmental Protection Agency, which regulates pesticides and heavy metals in the crop side of things. And so those are the regulating bodies. But what you can do right now is go look at the rules for other foods and things like that. So if you want to know how much solvent is okay to be in your product, maybe go look at what they regulate in peanut butter or olive oil or canola oil. And so if you've been okay with putting that in your body for your whole life, maybe that's at least a good starting point. But it has been good for the industry to kind of get people thinking about these things from the hemp and cannabis side, because then you wonder, wait, how much solvent is in my canola oil? And I bet nobody's ever asked themselves that question, but if you went and got it tested, there would probably be some solvent in your canola oil. And so there are rules and limits that are in place already. So with heavy metals in particular, again, this might be kind of scary, but this is an FDA guideline from 2006 on how much heavy metal can be in candies that small children are eating. And so it says it should not exceed 0.1 parts per million. And so now you go look at this hemp test, and you're seeing, okay, 0.1 parts per million. Okay, that exceeds that number, so now should I be scared? This is terrible hemp. But if you think about, okay, that's in candies that children are eating. So if this hemp goes through all this processing, and at the end of the day, the final product has these numbers, you can then start to do math of, okay, how much of this final product would I have to eat for it to be bad for me? And so I did that math, and it would roughly break down to, even with California standards being the most stringent in the country, you'd have to eat 1.4 roughly kilograms of product a day. So 1 kilogram is 1,000 grams, and an active dose of, say, CBD or THC is anywhere from 10 to 100 milligrams. So you're talking thousands of that per day to even get close to the most stringent California regulation. And so, again, a little bit of heavy metal is not the end of the world in that sense, because you're not eating anywhere near 1.4 kilograms a day. But again, it takes a lot of effort to kind of go through all that and understand it. And I can spend my time doing that, but I don't think the consumer should have to. So that's why it will be important for the FDA to step in and say these are the strict limits, because every single person buying hemp oil off the shelf can't be expected to do this math and figure out if they violated that or if it's healthy or not. Same thing with residual solvents. We have 149 with heptane here. So is that terrible or is that meh? So it's right above the lower limit here. So if it had been 49 parts per million less, it would have shown up as 0 on this test result, right? And so that's one thing to think about. And then again, the top side of this number in all of these solvents is 2,000. So what the USP actually limits on all of these, they're called class 3 solvents, and ethanol is included in that, is that if you have less than 5,000 parts per million, it's okay for food. So they don't even go up to 5,000 in this because, even if it's above 2,000, you probably wouldn't want to eat it, though it's technically legal. And so 149 is really close to the bottom limit there, and it's essentially not there, especially compared to any of these that could have been 50 ppm less and be good to go. And so again, the onus is currently on the consumer and the people buying the product and making the product to self-regulate and to understand this kind of very complex regulatory environment until there's regulation. And so that's why, in general, I wanted the talk to cover how you understand these things and how do you start thinking about it so that you can protect yourself and consumers can also be protected by good, responsible manufacturers. And I just kind of like to end, if you're ever buying a hemp product, a marijuana product, and you ask for a COA and they say, no, you can't see the COA, that should be a red flag, right? So I think most of the good actors in the industry understand the concern here and understand what you can do if you're not careful about how much solvent's in your product or you don't really care about consumer safety. And so the most reputable companies will say, yes, thanks for asking for the COA, here it is, and you can at least trust that they're willing to give you that. So if people don't want to give you the COA, that's a kind of starting point red flag. So with that, hopefully it wasn't the most boring, terrible talk first thing in the morning, but please, any questions you have. Thanks. No questions.
Feel free to ask.
Could you comment on, say you have a huge bucket of CBD, could you comment on what 149 ppm of a heptane solvent, like what that size-wise is, how much is in there, what that means?
Yeah, so say you have a kilogram or 10 kilograms of CBD, and it gets tested and you see 149 parts per million. Again, without a chemistry background, that means nothing really. It's a number on a piece of paper. In reality, that's in that big bucket, that 10 kilograms of CBD, essentially 1 drop of heptane. And so in the whole bucket, distributed evenly. So it's essentially a non-existent thing, but because the chemistry detection techniques are so sensitive, you can get down to that. And with solvents, again, it's well known that that 1 drop in the entire huge bucket is not going to do anything to you, especially unless you ate that whole bucket in that one day, and even at that point, it's still not going to do anything to you. So it's a kind of a crazy amount of detection that you have on that end. Anything else? There's one there.
So at this point in time, is the COA from distributors that provide or that sell CBD, is a COA required, or is it just kind of like an added benefit at this time to retailers that want to purchase it to put it in their products?
Yeah, it's not required. There is no law on how much heavy metal, pesticide, cannabinoids can be in things. And it's not required at all by the FDA because the FDA still says you shouldn't even be eating any sort of cannabinoid. And so it's just a best practice right now. And what I would say too is make sure if you are, because I would again definitely recommend don't buy anything without a COA, and then make sure that that COA is coming from an ISO accredited lab, because there's labs springing up all over the country for specifically hemp and cannabis testing, and that's great, and I think a lot of them do great work. But if they're not at least validated from the ISO side of things, then they could just be changing numbers, right? This is a PDF or a Word document, and you could just delete it, put 0 there. So that's why you need that regulation, so you can trust the testing labs as well. Anything else? else?
Does the COA of a crop tell you anything meaningful about the seed that that crop is going to produce?
Yeah, so the COA, if you know, the COA of the final flowering bud of they say it came from this seed and this is the final flowering bud, it does tell you a bunch about the cannabinoids, and you can get a COA for terpenes as well. And so if grown under similar conditions, you would expect that you'd get very similar cannabinoid potencies. So if it's a hemp strain, you can get, say, we'll go back to, because I think this is a COA of a hemp strain. So this is telling you how much cannabinoids that seed would ideally produce if you grew it in the same conditions. It's showing you that it's below the legal limit of the 0.3% THC. And so this would be an industrial hemp strain that can get you that, 5%, 7%, however much cannabinoids. It also tells you if you're interested in CBG or CBC or the other cannabinoids, how much are growing in that strain. And then I don't have a terpene one here, but it would also tell you the general terpene profile. And so it gives you a broad picture of what to expect, but growing conditions can also vastly change this. And so it's like a guidebook, but if it was really rainy, really hot, there wasn't good soil, nutrients, then it would change a bit, but it's a good guidebook.
Hi, I did a little preliminary cost analysis, I guess, for how much these tests cost, maybe around $600. Is that a good estimate?
That is a good.
For the single test.
Yeah, for the full panel. So each individual test here depends on the test. So I'll go to this list and I can give you a guess. So heavy metals and pesticides require the fanciest, most expensive instrument. And so those tests are anywhere, say, $100 to $200 to get it done. And then residual solvents and cannabinoid potency and terpenes require less fancy instruments, and so maybe all three of those together would be 100 or 200. And then moisture content, again, that's mostly for the hemp and isn't really applicable to final products for the most part. And then microbials, so we send every batch, so every week, at least one batch result per week, and so it's $600 plus per batch. And then if you get the results that are bad and you have to retest, it's another $600. And so yeah, our monthly bills for analytical labs are in the 5,000 to 10,000. I mean, we do a lot of production, so it wouldn't, maybe be everybody's bill. But yeah, I think 600 for all of these tests is a good guess. And so yeah, and then you kind of see that that's an expensive, proposition. And if you're a small company, that's going to eat into your margins quite a bit. And so I understand from the other side of, I'm doing the best and I'm trying to make my own hemp oil, but I can't afford every kind of batch on that. And then if regulation comes in, that could put a lot of people, in a tough financial spot. But unfortunately, because of the people who like to skirt the law and, don't care about how much solvent's in their product, it does kind of get to a consumer protection. And then if you wanted to build this, so this is actually our own facility. This is like the most expensive room in the entire facility. Each one of these instruments is roughly $100,000. And so this is a $300,000 bench top right there. And that's just the price of those instruments. You can get them used, but then you have to have somebody who's trained to use them, right? They're not just like you put your thing in and it spits out a number sort of thing. You have to be a chemist to even operate them. So it is expensive. But yeah, I think to protect consumers from some of the bad practices, it's kind of required.
Thank you. Do some of the portable testing devices provide the same type of test results?
I think my opinion here is that probably not would be my 2 cents. And I think it's possible, right? I'm not going to say it's impossible. But like these are the instruments that are used in all food production, all drug production, and there's a reason, that it's so expensive. And I think the portable ones, can get you some useful information as far as like a rough ballpark, because when I was talking about, I guess the scale metaphor is pretty good, right? These instruments are just different versions of the scales, right? So if this is the one I was showing you, the really expensive one, gets you that 4 decimal place accuracy, which you really care about on some of the stuff, maybe the ones that you're getting that are portable are closer to this. So it's better than nothing, but it's not like, food grade or pharmaceutical grade compliance probably. But if it's just for your own purposes of like kind of, I want to quickly know how much CBD is in my hemp strain out in the field, plus or minus 10% is at least kind of getting you in the ballpark. But if you're going to put something in your body and hope that it has no THC because you don't want to get high or fail a drug test, I don't think you really want to rely on a portable one because again, if it's close to that limit or it gets above it, you could be getting high and kids could be getting high who are taking these oils, or you could be failing drug tests and getting fired. So, yeah.
Is there a list of permitted analytical variations that exist that you can reference with regards to these assays?
Yeah, so there's not any. I think actually for marijuana, depending on the state, there probably are some specific requirements that the testing is, you have to do this and this and this to be within the marijuana side of things. With hemp, there's really not. But I guess if you're asking more about the different tests to do these things, so heavy metals has to be done on like this one really fancy instrument. It's just the only way to do it. It's called an ICP mass spec, and so it's very fancy and expensive. Pesticides can be done with, I think, gas chromatography mass spec and other mass specs, and so that's kind of the general route. And these two exist for all crops, and so what I think the industry has been doing is what's required for corn or something like that. So these instruments and the methods to test for those pesticides exist. Then with cannabinoid potency, that's obviously unique to just the cannabis plant, and so those are that can be done with a GC, a gas chromatography instrument, or a liquid chromatography instrument, LC. And then terpenes have to be done with the GC for the most part, gas chromatography. And the residual solvents also have to be done with a gas chromatography. And so those are the kind of equipment and methods that need to be done to detect these things for the most part.
So back to the original question, AFCO gives standards where, let's just say you looked at protein or fiber or something in an assay. They give plus or minus 10% permitted analytical variance from the laboratory for a tolerance. Is that something that's out there with regards to these type products?
There's really not. I think there is, again, if you go to, say, a different industry and say, what's the variance allowed in corn protein content, if it's plus or minus 10%, then the lab should be following that. But because they're not, I think if they're ISO certified, there is a variance that they're required to be within. But if they're not ISO certified, they don't even have to report it. So you could say, well, what's your variance? Is it plus or minus 5? Is it plus or minus 10? And ISO labs have to tell you that. I think legally they're supposed to. Whether or not they will, I don't know. But if they're not ISO, they can just say, we don't want to tell you that. That's our proprietary information. And so I would like it if all of these reports had the variance listed on them, but most of them don't.
Thank you.